Hello dear. Today we'll try to understand about geometric change in population. So geometric model is one of the important model to understand and estimate population, past population trend and estimate the future population. Under geometric change, the successive population totals differ from one another by a constant ratio irrespective of arithmetic model where the successive population totals differ by a constant number. Here the successive population totals differ by a constant ratio. In other words, the population totals for successive years form a geometric progression in which the ratio of adjacent totals remains constant. As for example, this is one geometric progression 2, 4, 8, 16, 32. If you try to calculate the ratio between two successive population, here it is 2, here it is also 2, here it is also 2 between 8 and 16. So the ratio between two successive population will always remain same in case of geometric progression. So geometric population growth is similar with the growth of a bank balance receiving compound interest. The interest is calculated each year with reference to principal plus previous interest payments, thereby yielding a far greater return over time than simple interest. So here we basically use the compound interest formula to access the past population trend and also to predict the future population. A geometric series is one in which the population increases or decreases at the same rate during its unit of time, usually a year. So graphically, if you plot the population, then the geometric growth can be visualized like this. So mathematically, Pt equal to P0 under bracket 1 plus R to the power T. In case of commerce, here you used to consider A here, amount, and here is the principal amount. R is the interest rate and T is the time interval. But in case of population, we consider this formula Pt equal to P naught, then under bracket 1 plus R to the power T, where Pt is the population at Tth year, P naught is the population at initial year of calculation, means from which year you want to calculate, which year you consider as base year to project the future population. So doing simple algebraic equations, we can find out the value of R, which is equal to Pt by P naught to the power 1 by T minus 1. So with the help of this formula, you can actually project a future population. Suppose you want to project the future population of 2021, then considering the base population of 2011, then you put the population of 2011 here, then 1 plus the growth rate, the annual growth rate of population between 2001 and 11, then you put the time period here. The time period from base year to the projected year will be here. In case of our example, it will be 10 here. We'll also try to understand these things and try to calculate this in our Excel sheet. Let's have a look. So let us look at this data set. We have this year 1951 to 2011 and we have the data in thousand population data. Now we have to calculate the geometric growth rate between 1951 and 1961. So what is the formula of our growth rate? It is Pt divided by P naught to the power 1 by T minus 1. Okay. So let us first here write growth rate. So we are going to calculate the growth rate between 1951 and 1961, between these 2 years. So what will be our PT then? This will be our PT, the final year population, and P0 is the initial year population. So write down equal to, select this one, divided by this one, then we get the value of 1 point this value. Now what is the time interval here? It is 10. So 1 by 10 is 0.1. We can also calculate this, equal to 1 divided by 10 equal to how much? 0.1. So here we have to power this value with 0.1, isn't it? So equal to this, select this value PT by P0, then put the symbol of power, then 0.1. So this is the value of PT by P naught to the power 1 by T. Now again we have to subtract it by -1, is not it? Let us put this. So we have to do nothing here, just put equal to and select this one, then what? -1. So this is our annual growth rate between year 1951 to 1961. Similarly, we can calculate the of other years, 61 to 71, 1971 to 81. So we can do one by one also, no problem. Suppose equal to between 71 and 20. So this divided by this, then equal to this to the power 0.1 equal to this minus this. Like this also we can do one by one, or we can manually pull it like this. And also get the result. You can get the result like this. So these are the growth rate. We can reduce the decimal point. So this is the annual growth rate for this year. Now we have to project the population for 2021. What we have to select? We have to select the growth rate between 2001 and 11. We have to select the growth rate of this value. So here we have to put in place of R this value. Then P0, what will be our base year population? This one 31205. And what will be the time period from 2011 to 2021? It is 10. Put the formula here for projection purpose. Now equal to 1 plus, what is our R? This one is our R. So we will select this one R. Okay. Then 1 plus R to the power T. So equal to, this is 1 plus R value to the power, what is our time period? It is, as we are going to calculate for 2021, the time period is 10. Okay. Now our P naught value is which one? This P naught is our base year here. So we select this one, then multiply by this one, 1 plus R naught. So we get the value. So this is our population. So ignore the decimal point here, as population cannot be in decimal. So this is our projected population for 2021.